Here's a quick intro to the reinforced concrete column module, following New Zealand's code NZS 3101. Let's say you've modelled your structure, applied the loads, and now it's time to design the reinforcement for this specific column. SpaceGas simplifies this process and ensures your design meets the requirements seamlessly. All it takes is a right-click on the column, then select Edit Concrete Column, and you're good to go. By default, SpaceGas designs an optimised reinforcement arrangement tailored to the external loads and code requirements, ensuring compliance and efficiency. One of the standout features of this column module is its ability to create a 3D interaction diagram that shows the relationship between biaxial bending and axial load. It's a powerful visualization tool for understanding column behaviour. Biaxial bending in reinforced concrete occurs when a column is subjected to bending moments around two principal axes simultaneously, along with an axial force. To visualise this complex interaction, a 3D interaction diagram is often used. The diagram typically has axes representing the bending moments about the principal axes, MZ and MY, and the axial force, P. If the resultant load point, P, MZ, MY, is located within the 3D interaction surface, it indicates the member can safely resist those loads within its capacity. Conversely, if the load point is outside this surface, it signifies the member is overstressed and therefore unsafe. Clicking on a resultant point load brings up detailed results, including magnified bending moments, bending moment capacities, axial capacity, and buckling capacity, all presented in an accessible format for thorough analysis. Double-clicking on a resultant point load opens a 2D interaction diagram showing MZ and MY at the corresponding axial load for that specific load case. Just like in the reinforced concrete beam module, you're not bound by the default design. You can freely adjust the reinforcement arrangement to suit your preferences. For instance, I'm going to update all the bar diameters to a new size. You can clearly see that SpaceGas recalculates everything automatically to incorporate the updated input, ensuring the new design parameters are accurately reflected. Let's deliberately make a change by assigning an unreasonably small and unacceptable bar diameter, just to observe how SpaceGas responds to such an input. The first observation is that the beam has now failed, as expected. The second observation is that many resultant point loads have now shifted outside the safe surface. This illustrates that the column is overstressed and unable to handle the applied loads under the altered design conditions. The resultant point loads are colour-coded for clarity. Red indicates points that have fallen outside the safe surface, signalling failure, while green represents points safely within the surface. The column module generates a detailed report that includes checks for bending, shear, and torsion, offering a comprehensive analysis to ensure the column meets design requirements. Here is a quick demonstration of a circular column this time, as opposed to the rectangular one we looked at earlier. Thank you for watching, and I hope you enjoy using SpaceGas software.